All right, so on the partner surprise quiz, just some very, very, very basic things. We need to be able to take some ordered pairs, and that's what A, B, and C are. A, B, and C are ordered pairs, and we need to be able to build the vectors. In problem number 1, A, that is the vector from A to B. Direction is important. A to B. So how does vector AB move? Well, in the x direction, it goes forward 2, and in the y direction, it goes down 3. So the coordinates of vector AB, sometimes called the directed distance, are 2, -3. Now, in order to do this is called a scalar. We're going to multiply the coordinates of vector CB by 3. So C to B, C to B. So 0 to 3 and 4 to -5. So the coordinates of 3CB are 9, -27. Easy peasy. What does the absolute value notation mean? Magnitude. And if you want, you can draw a picture of this vector, but as I said repeatedly in the video, magnitude is always found by squaring the components, adding them up, and taking the square root. It's the Pythagorean theorem. So the magnitude of V is going to be -3 squared plus 6 squared. So that's going to be the square root of 45, which is what, 3√5? 36 plus 9?
What do we have to rationalize?
Simplify? Yes.
Would it not be -9?
When you square something?
No, it's in the absolute value.
No, that has nothing to do with it. You're squaring it. You're squaring it. Okay. Now, 2b minus u. Better figure out what that is, and then we'll find its magnitude. So what's 2v? 2v is -612. And u is 1,5. And I am subtracting them, so that's going to give me, that's going to give me what? -6 minus 1, -7. And 12 minus 5, +7. And I need the magnitude of that. So I square, add them up and take the square root. So that's going to be 7√2, isn't it? Square root of 98. Okay, so again, all this was covered in the notes. We're just kind of going through it real quick to kind of pull some of the pieces together. All right, AC has to equal DB. Okay, so what are the coordinates of AC? AC, we'll be careful, we're going from A to C. So A to C is going to be -1,6, isn't it? And I do not know D. So vector DB, vector DB starts someplace and ends at 3, -5. And it travels like this. So where do I have to start so that if I back up 1, I'm at 3? That's what this means. Where do I have to start? So I go back up 1 and I end up at 3. Doesn't this have to be 4? Now I don't care how your brain is processing that, get 4. It's got to be 4. And then where do I have to start so that if I go up 6, I'll be at -5. -1. So there are the coordinates of point D. U, vector U, has coordinates of 1, 5. What is the magnitude of vector U? How long is vector U? Square root of 26. 1 plus 25, so the square root of 26. U then is not a unit vector, because to be a unit vector, it means your magnitude is 1, and this is root 26. So who remembers from the video, how do we turn any vector into a unit vector? Lucy? Couldn't hear you because they were blabbing. I divide by the magnitude. So I simply take 1 and divide it by root 26, and 5 and divide it by root 26. I don't care if you rationalize that or not, it's fine if you leave it like that. If you want to rationalize it, go ahead. Okay, next. Find the components of the vector whose magnitude is 7 and whose direction angle is 187. So here we go. Here we go. 187. 187 would be down here like this. Would you agree with that? This is 187. And the magnitude of the vector is 7. My job is to find the x and the y. That's what we mean by components. Find the components of the vector. Okay? Now, who was really watching the video? Because I gave you a couple of options. Does anybody remember what those 2 options are? Sydney?
You do. I know this. It's got the distance for. Wait, is it? No. Is this the one with the? It's like the AB cosine thing.
No.
Okay, never mind. I don't know.
But it does involve cosines.
Okay,
for sure.
yeah, I thought
Yeah.
it was.
You subtract 180 from 187 to give you the angle measure.
Okay, so one option is to find the reference angle, which is 7, and then to do SOHCAHTOA trigonometry. So cosine of 7 degrees, that's a degree measure, is x over 7. So x is 7 cosine 7, and then sine 7 equals y over 7. So y equals 7 sine 7. Now, that will work every single time, but what is my caution? If that's how you choose to do the problem, already busted you once today, pal.
I slipped my mind before I apologize.
It's not my infractions, I mean. If you do the problem this way, using the reference angle, then you have to remember to manually go back and put in the correct SIGNs. So this vector is in quadrant 3, which means its x and its y are both going to be negative. That will always work. You just have to remember to make the sign adjustments, the SIGN adjustments. What's the other option?
Magnitude times.
Would you do 7 cosine? 187?
Yeah, you can use the angle that you got. You can use 187. If you do 7 cosine 187, you are going to get exactly the answer Liam got when he did this, except that one's going to automatically come out negative. So you can, we are programmed to draw triangles, and so I get it that this is what you want to do. It'll work every time, but you don't have to do it. The components of the vector are magnitude cosine theta, magnitude sine theta, period, every time. Okay? All right, and you're going to get whatever the decimals are. That will be your answer. Don't say it out loud because they were actually doing a quiz. What is the vector word for sum? The vector word for sum is resultant. So, when you have a question that says find the resultant, you immediately know that means you are to find the sum. All right, get out the one that's called review 6.1 to 6.2.
It's negative 6.9
We're looking at the one called Review 6162 now. The other thing I gave you is the whole chapter review. So we're not gonna look at that for a while. That's the chapter review for the whole chapter. All right, fine. Oh, wait a second. Didn't we just do problem number 1? Find the components. The components are going to be 14 cosine 237 and 14 sine 237. You do not need to draw a triangle and do the reference angle thing, but you are absolutely welcome to do that. But again, this vector's in quadrant 3, so your x and y will be negative. If you do this, they're gonna come out negative. It's just gonna work every time. I had another caution for you in the video though. What about doing this with the navigation problems? Yeah, you can, but you have to adjust your angle to put it in standard position. Yeah, it has to be in standard position. All right, so now I got a triangle, CHS. My job is to find the measure of angle C, and all I know is that this point is 1, -2, this one is -6,4, and this one is -1,7. So I've been given 3 points in the plane. Obviously, if they're non-collinear, they're gonna make a triangle. And your job is to find that angle of the triangle. So I want you to think about all those notes you took. Was there any conversation about finding angles in all that? Yes, there was. Josh, you gotta use the dot product. But, Josh, yes, I'm gonna use the dot product. But guys, you dot vectors. So don't be finding dot products with these guys because these guys are points. So the first thing you gotta do is build the vectors that you wanna dot. And since this is the angle you're looking for, the vectors you're going to build are vector CH and vector CS. Those are the 2 vectors that are creating angle C. Back to geometry. An angle is the union of 2 rays with a common endpoint. So if you are doing angle C, then they're emanating out from C. So CS and CH. Okay, we already practiced that. What are the coordinates from C to H? -7, 6. What about from C to S?
-2, 5.
Perfect. Okay, now we're gonna dot those 2 vectors, both ways. So one way to dot them, anybody remember? What's like the easy, fast way of finding that product? X times X. CH dot CS is gonna be -7 times -2 plus 6 times 9. So what is that?
40.
Isn't it 68?
I think it's
Yeah, 68.
5 is 42, which is 4. Or no, 68. Because those are double negative.
Yep, so our dot product 68. Okay, so one way to calculate a dot product is to take x times x, y times y, and add them up. But again, I'm going to caution you, kids, you dot vectors, not points. So before you do any dot product, make sure you're working with vectors. Okay, all right, so what's the other way of finding the dot product? There's another way of doing it. Magnitude of first vector. All right, what's the magnitude of this guy? 49 and 36 makes 85. Square root of 85. Times magnitude of second vector. Oh my gosh. Is it also 85? Coincidence, coincidence. And then cosine of the angle between them. Okay? So, since the dot product is 68,
Holy cow, man.
I can say 68 equals all that. Well, those two, usually it's some big radical we get, but they happen to be the same, so just 85. Cosine C. So what do I type into my calculator to find angle C?
First cosine 68.
Second cosine, oops. Second cosine 68 divided by 85. And did you get 36.87 degrees?
She got that, that's what it is. 60, that's also.
All right, next, we are gonna find the magnitude and direction for this vector right here. Now, who remembers what I and J are? What are I and J? They are the horizontal and vertical unit vectors. So this is exactly the same. What this is saying to me is, this vector goes right 1 and down 4. So the coordinates of that vector are 1, -4. It's just another way of writing it. So if I look at the vector 1, -4, it looks like this, right? My job is to find its magnitude and its direction. Well, magnitude is a no-brainer. What's the magnitude? Over 1 down 4, that's gonna be square root of 17. So the magnitude is root 17. Now, this will be the direction angle. We've done this kind of thing before. We'll find this guy right here, right, I'll call it theta, we'll find him by saying the tangent of theta is 4/1. Now, I'm looking for the reference angle, so I'm not messing with the negative. If you wanna mess with the negative, it's okay. Just not negative. So that angle is what? Second tangent 4, 75.96. So what is my actual direction angle then? Oops. 284.04. Right? By the way, we normally answer these in degrees, so it's not a problem, but some of you really got wigged out when I asked you to find an angle in radians. Some of you were like doing all kinds of craziness. Guys, if you want that answer in radians, just change your calculator to radian mode. It's gonna come out in radians then, right? So you don't need to be doing all the stuff you were doing. All right, next, number 4. Find the actual speed and direction of a plane traveling 400 miles on a course of north 17 degrees east if the wind is blowing 72 miles an hour on a course of 160 degrees. Now, you've all experienced this, whether you were riding your bike or driving your car on a windy day, you've all experienced this. You can be heading in one direction, you know, but then that wind blows you and it blows you off course, right? So that's what we're trying to do, is figure out what has the wind done to my actual speed and my actual direction. Isn't my actual speed and my actual direction the resultant of my motion and the wind? Aren't they being added together? So I'm gonna find the coordinates of my initial speed direction. So here's the plane. All right? Now his speed is 400 miles an hour. So I'm gonna do 400 cosine, 400 sine, some angle. But I'm not gonna use, obviously I can't use north 17 degrees east. What angle does that correspond to in standard position? North 17 degrees east would look like this. Would you agree with that? The standard position angle is this. So what angle is that? That's 73, isn't it? So here are the components of the airplane. Now I'm going to do the same thing for the wind. His magnitude is 72. And it's a course of 160 degrees. So, navigationally, 160 degrees would be this, right? Remember your compass, guys. Can't forget it now. Gotta remember your compass. The standard position angle is this one. Liam?
Couldn't you do negative 70 as well?
You could actually. We like to say positive, but you absolutely could do. He said, couldn't I use this as my standard position angle? And it is a standard position angle, so that will work. Is that one easier for you to find? Negative 70? We can use negative 70. So that angle is negative 70 degrees.
Would the other one be 290?
Yes. Okay. Now, what am I trying to do? I'm trying to find out what happens when those two get added together.
So 160. 160.
So I am simply going to take 400 cosine 73 and add it to 72 cosine negative 70. And then 400 sine 73 plus 72 sine negative 70. Kids, when you add two vectors, you're finding the resulting x direction and y direction. So you add their x's, add their y's, and that's what happens. So what do I end up with here? 400 cosine 73 plus 72 cosine negative 70. 141.57. And then 400 sine 73 plus 72 sine 314.86. Now, does that look like what you got?
Yeah.
All right, I want to make sure I'm answering the question. Find the actual speed and direction of a plane traveling, okay. I haven't done that yet. What have I found? I have found the coordinates of the resultant vector. The resultant vector is over 141.57 up 314.86. You see what I'm saying, guys? I haven't answered the question yet. I've got my coordinates. But now I need the magnitude. This is going to be the actual speed. This is going to be the resultant speed, that magnitude. So how will I do that? Square 141.57 plus 314.86. Add them up and take the square root. The resultant speed of this plane is 345.22 miles per hour.
This is one of those where you wouldn't take off your sound off.
No, yeah, I didn't get what I got there. Okay, now here's the deal, kids. The problem started, the original problem started in terms of magnitude and direction, right? That's how it started. I changed that into the component form so that I could add them together. So now I gotta change it back to its magnitude and direction. So what's the direction? Well, technically, the direction's gonna be right here, right? Because we measure from due north. But I can find that by finding this angle and subtracting from 90. So that's what I'll do. Second tangent, 314.86 divided by 141.57. So this angle right here is 65.79. So I'll subtract that from 90, and my actual direction is 24.21 degrees. Test?
Wait, so when it says force and bearing, it all starts from
Due north.
zero?
Always got it. You always got it.
You always use the angle that starts from X.
What?
Doing the sign.
What?
You always use the angle that starts from X. The x-axis.
Yes, that's standard position. That's standard position, yes.
I'm confused because when I did the tangent of -1, I just got 24.21 right away instead of 65.
I could have typed it in wrong. Second tangent, this number divided by this number.
Oh,
314.
I put them backwards. That's
Okay, tangent's opposite over adjacent, right?
Yeah, I found one the other way. Take this.
All right, last one. Find the work done by a force of 48 pounds acting in the direction 2, 1 in moving an object 4 feet from 0, 0 to a point in the first quadrant along the line y equals 4x. Wow, that sounds complicated. So, first of all, let's remember how to calculate work. How do you calculate work? What am I going to need to know in order to answer this question? Force. That means the magnitude of force. Times distance. Times cosine of the angle between. So I want you to think about what's happening in this problem. First of all, do I know the force? Do I know the magnitude of the force? 48 pounds. Do I know the distance? 4. The only thing I don't know is the angle. So I'm going to kind of look at this situation. I've got a force acting in the direction 2, 1. So that means over 2, up 1. So this is the direction of the force. But the movement is along the line y equals 4x, which has a slope of 4 over 1, which means it's going over 1 and up 4. So my black line is the direction of my force. The orange line is the direction of the movement. Okay? So remember, like if you grab a hold of a wagon and you start pulling the wagon, the movement is on level ground, but the force is coming in at the angle of the handle of that wagon. So force and movement do not always have to be in the same direction. They usually aren't in the same direction. So we need to find this angle right here. Now, remember, that angle really has nothing to do with any specific magnitudes. It just has to do with, I got a couple of vectors, one could be longer or shorter. That doesn't change. Would you agree that if I make this one a lot longer and leave that one short, isn't that angle still gonna be the same? So I don't want you to get all hung up about that. I want you to stop and think. This is in the direction over 2, up 1. So I'm gonna assign that vector coordinates 2, 1. That's how it's moving, over 2, up 1. Now, how is the orange one moving? Over 1, up 4. So here are my 2 vectors. Those are the 2 vectors that I need to find the angle between. So how do I do that? We already did that on another problem. How do you find the angle between 2 vectors? You find their dot product. So what's the dot product of these 2 vectors? I'll call them U and V, I'll just bother. So U and V is x times x, y times y. Add them up, 6. What's the other way of finding the dot product? Magnitude of the first, square root of 5. Magnitude of the second, square root of 17. Times the cosine of the angle between them, which, oh, by the way, is what I'm looking for, right? That's what I'm looking for, right there. So if these 2 equal to each other, multiply that together. What's the cosine of my angle? The cosine of my angle is 6 over root 85. I don't even need the angle. Formula just says what's the cosine, right? So what's 48 times 4? 192 times 6 over root 85. Did I multiply right? 48 times 4. Yep, and then times 6. So 1152 over root 85 foot-pounds. That's the amount of work that I did. Okay? All right? So, next time, is that tomorrow? Nope. Next time I see you, seems like I never see you. Next time I see you, we're gonna have a little quiz over 6-1 and 6-2. You just practiced. We did that quiz the kids took by surprise with a partner, which has a lot of this on it. We just did this one, which has the word problem types on it. You have your notes, and we're ready to rock and roll. Okay. Now, we're going to do one problem from 6-3 though. I have got to get going here. So one problem from 6-3. I want you to forget the by hand part because we don't have a lot of time. I want to do this first on the calculator, which is problem number 2. Okay? So problem 1 says graph this by hand. Problem 2 says do it on the calculator. So we did this earlier in the year. This is 6-3, number 2. We're going to graph this set of parametric equations on our calculator. So go to mode. Right? Everybody go to mode. And one of your options down the line is PAR. See it? That's going to allow us to graph in parametric mode. We discussed parametric equations earlier in the year, so you recognize that. So when you press Y equals, it now asks you to put in an X value and a Y value. So for X, you're going to put in T squared, and T is your variable button. Now, in parametric mode, you just press your X button, it's gonna come up a T. So T squared minus 2. And then Y is 3T. All right, now you can go ahead and hit graph. I have no idea what you're gonna see because I don't know how you set up your window. Did you see a sideways parabola? Then you're good to go if you see a sideways parabola. If you don't see a sideways parabola, there are a couple of things you might want to consider in window. First of all, the problem tells me that my T's, so my T min is -3, and my T max is +3. My step is set at 0.1. You might try that, it's not the only thing. And my X's and Y's are just a standard window, -10 to 10. So make those adjustments and try it and see if now you get a sideways parabola. Everybody got it? Okay, so we're gonna graph this by hand next time and we'll get a sideways parabola. But the beauty of parametric and polar, that's all in this chapter, the beauty of it is you can graph things that aren't functions. This is not a function. In y equals mode, you can't graph it. But we can graph it. All right, that's enough for today. One problem. Woo-hoo.